Okay, welcome back, ladies and gentlemen. I started to go into wind speeds in the last video, and I decided to just come back a little bit and just slow it down so I can make this video very palatable. Before we went into wind speeds and higher altitudes and things of that nature, what we needed to do was talk about wind. What is wind? How it's created, and the factors that play into the creation or generation of wind. How is wind created? Wind is something I guess we need to step back and define. It's just air in motion. But what I wanted to do in this video is to come back and say, okay, well, what makes the air move? Now, in a previous video, and that's why I encourage you guys to watch these videos in sequence, and the meteorology for professional pilots in sequence, because what I want to do is make sure you guys have a thorough understanding and grasp on what's going on. So, in an earlier video, we talked about high and low pressure. Alright, and in the atmosphere, normally you have higher pressure towards the sea level or ground level, or let's say sea level. And then as we climb and go to higher altitudes, now this little guy's climbed up the mountain, and now what he has or she has experienced is lower pressure. The density of the atmosphere has decreased, and you can see the atoms here, how they're closely pressed together because we have higher pressure, and we can see how the atoms are spread apart because of lower pressure. So sometimes we have pressure systems that get beside each other. We come back to our weatherman, and we can see high pressure areas, low pressure areas around here, and at this point we should understand that we get clockwise wind movement. The winds move clockwise around the high pressure areas and counterclockwise around the lower pressure areas. So coming on back to our high and low pressure areas, the air movement in the high pressure area is down, moves down, the air moves downward, and in the lower pressure it moves upward. And here we can see the counterclockwise movement in the low pressure and the clockwise wind movement in the high pressure area. Now, the best example I could come up with is a balloon. When we talk about pressure systems, we come back here, we have our pressure systems, the high and the low pressure system. So just think of it as this balloon. This balloon has been tied off. Okay, it's been filled up and then tied off, and there is higher pressure existing in this balloon. So this is our high pressure system, and this high pressure system is contained. Well, in weather, that doesn't happen. Everything is contained in the troposphere, but this balloon, just think of this as a high pressure system, and the outside air is a lower pressure system. Now this balloon will be open in a weather, if we look at it from a weather perspective, this balloon will be open, and then the generation of wind occurs. Okay, so what I've done is I've taken this balloon, turned it sideways, to kind of give you a representation of what happens. So the higher pressure system moves air, wind, to the lower pressure system. Here's another one. So that movement of air is called pressure gradient force. Okay, so we have higher atmospheric pressure here, higher pressure system here, a lower pressure system here, and air moves. Gradient is like a tendency of movement. It's a tendency of the higher pressure to move to the lower pressure area. So that's basically what pressure gradient force is. So we come back to our high pressure, low pressure system, and we put our balloon there. And I know it looks tied off, but just imagine that this balloon is open now. So what's going to happen to the air inside it? It's going to move outward to try to equalize. All right, so that's one factor that plays into the creation of the movement of air or wind. Now, in this example, back to our weather guy, this high pressure system is going to try to flow and feed into this low, this low, this low, this low. And here's a better representation. We have 4 high pressure systems around here, and we can see how the wind or the pressure gradient force moves the air towards the low, and that is how we get our wind. Now, wind speeds, we come back to our isobars. Our isobars are like speed, the speed measurement. We calculate speed in miles per hour in some type of unit. We use millibars when we look at these pressure systems. So we have 1,000 millibars there, 1,005 millibars here, 1,010 millibars here. So these are noting, these numbers are noting the pressure in a unit, in a given unit. So we have low pressure here, 1020, 1020 millibars here, that's high pressure. Higher, this is lower pressure, 975 millibars. All right. One thing in this slide that I wanted to show you is that when the isobars are close together, you get stronger winds. When the isobars are farther apart from each other, we get weaker winds or slower winds. So basically, in the text, when you see this little scary, some people be like, oh, I don't understand this thing, it looks like Chinese. Now we're going to talk about friction in a minute. We've already talked about Coriolis force. We just talked about pressure gradient force. It's just the tendency of the high pressure to move air to lower pressure. And then this is just the resultant wind. So this high pressure, when we can see these are the millibars, the contours that we see, like here, or I'm sorry, isobars. These are the isobars. All right, and these are measured in millibars. So the high pressure system is 1028, 1028 millibars, and then we can see the contour going down to 1016 millibars. And so we have our high pressure system and a low pressure system here, and then the air movement. Now the resultant wind, and let me just slow down. So just like our balloon, the high pressure system is going to move air towards the low pressure system, wind, movement of air, and basically other forces are going to try to, what's the word I'm looking for? They're going to affect it. They're going to change it. So the pressure gradient force, that's the balloon force. That's what this arrow means. If we look here, we start here. The pressure gradient force is going to say, hey, I want to go this way. I want to go towards this low. There's a lower pressure system here, and I want to move air to it, wind. But we have surface friction. When the winds get closer to the ground, they're going to play a part in acting against what the systems want to do. The air wants to move directly from the high to the low, but it will not, because of Coriolis force. Just the rotation of the earth is going to play a part in dragging it this way. And these are called vectors. A vector is just a visual representation of the forces. So the initial force that's causing the wind to move is just by pressure, or pressure gradient force. It's a tendency. All right. It's like if I am at the top of a hill, and I take a basketball and I just let it go. It's going to roll down the hill in that direction. But Coriolis effect and ground friction from mountains, buildings, I don't know what else, just terrain, basically, is going to want to drag it in this direction, and Coriolis effect is going to drag it in this direction. And the white arrow is just the direction that the wind is going to go. So, in a nutshell, wind wants to go this way, air wants to move this way, but friction and Coriolis effect pull it and apply force to it, and then the resultant wind, the whole result, takes it in that direction. So I hope that was clear. If it was not, just send me some comments and I'll revise the video if necessary to make it simpler. Now, for all our pilot people that are, student pilots and stuff, you should know what this is. This is a winds and temperature aloft forecast. Okay, if I'm doing flight planning out west, Seattle, the Denver area, DN, that's the Denver area, not Seattle, St. Louis, I'm sorry. You'll look at a winds aloft forecast to see if the winds are in your favor and at what flight level you want to fly at. And that's what the FT means. It's just the altitude. We have 3,000, 6,000, 9,000, 12,000, 18,000, 24,000, 30,000, 34,000, and 39,000, which is around the area of the tropopause. Okay. And we don't want a whole lot of wind in our face because it will slow us down over the ground. And I have other videos talking about, speed and ground speed. So basically, we're going to focus on the St. Louis area. Now, how do you read this? Well, you take the first two numbers and you add a 0 to it. 210. So the winds are coming out of the southwest. And the wind speed is 13 knots. Alright. Now, at 3,000 feet, 210 degrees, 13 knots. Now you're going to see a tendency here, but I won't give it away. Now if we move to the 6,000 foot block, the winds change from 230 to 230 to at 25 knots. So the wind direction 230 is more, it's still a southwesterly wind, which means that the winds are coming from the southwest. We come up to 9,000 and 230, 32 knots. So you can see that the winds are increasing. 12,000 feet, wind speeds up to 39 knots. 18,000 feet, wind speeds up to 56 knots. 24,000 feet, the winds speed up to 70 knots. 30,000 feet, 94 knots. 34,106 knots. Alright, so if I was flying southwest, I would not want to be very, very, very high. I would probably take a lower cruising altitude to minimize the wind speed in my face. I'd probably use a 12,000 foot cruising altitude instead of 39,000. I would not want a headwind of 119 knots here, so I would fly at 12,000, so I only have 39 knots in my face, because if we have wind blowing in our face, it's going to slow us down over the ground. So I hope that wasn't too difficult, and I hope you can figure that out. So that ties into friction. If we go back to our diagram here, friction plays a part in the creation of wind. Let's come on back down to George Bush. Alright, so we've covered how the winds are created and even how they are directionally changed due to pressure gradient force, friction, and Coriolis force. So those three key factors play in the resultant strength of the wind, wind speed, and direction. So here, this would give us a better idea of friction. As we go up to the higher altitudes, as we saw in our winds aloft forecast, where we had like 119 knots, 106 knots. The winds are very, very strong at higher altitudes. But then as the winds come back down, due to air circulation, the movement of air, the ground friction slows it down. All right, it slows down the wind speeds. So that is my point. When we talk about the creation of wind, we covered Coriolis effect. Another thing that I wanted to focus on is the movement of air about the systems, the pressure systems, and then I want to show you how give you another example of how ground friction, just the air, the winds coming down to the surface of the earth, how they're changed. Now, here is a low pressure system. Here's New Jersey, here's Pennsylvania, here's Ohio, under there is West Virginia. Alright, so that is the area. This is like the West Virginia area. Now, if we look at this, we close in, we go to another map here, New Jersey, Pennsylvania, Ohio. Here's that low pressure system that we had in this example. This is the low pressure system we close in. And we spoke earlier about how winds move counterclockwise around low pressure systems. Here's Cleveland, and this is the wind over West Virginia. This is what we're looking at. The wind over West Virginia is about 3,000 feet. So the winds don't have ground friction to interfere with it, and it just pretty much does its thing. And I wanted to note Cleveland. Now, when we look at Cleveland, CLE is the airport identifier. What I want you to do is look at this. We call this it's a flag, basically. It's what we call a wind flag. And what this, north is always the top of maps. East is this way. Okay, so if we look at Ohio, New Jersey is east of Ohio. All right, so sorry about that. So fly got in here. We look at this wind flag. The winds are coming out of the northeast here. All right. We come over here to this airport. The winds are coming out of the north. So north is up top, west is over here, east is over here, south is down at the bottom. All right. So the winds here are coming out of the north. We come down to the bottom under the low pressure system, and winds are coming out of the west. All right. So the flag, the top of the flag indicates where the wind is coming from. All right. So if we look at this system, we come over here to the eastern side, we can see that the wind is coming from the east. So this is an actual wind display at 3,000 feet. We could see that the winds are actually moving like they should be around the pressure system at 3,000 feet. Now note, Cleveland, the winds were coming out of the northeast. Now when we look at the surface, this is a METAR display. A METAR is just basically a, what's the word for it, or the phrase for it? It is a scheduled observation. Okay, pretty much every hour in the hour, the airport kind of just gives you weather information. Okay, and what we're focusing on in this video is wind. Now, previously we looked at Cleveland, above Cleveland at 3,000 feet. As noted here, at 3,000 feet, the winds were coming out of the northeast. Okay, because the top of the flag is pointed in the northeast direction. That means that the winds are coming from here and flowing this way. Wind starts here, flows this way. But then when we look at the surface, what the weather sensors actually on the airport, or we say on field, the weather sensors on field are telling us is that the winds are coming out of the north. So this gives us another idea how surface friction, just the wind and the earth and the surface of the earth. Anytime you get two things, and I don't know if you hear my hands rubbing together, anytime you get two things rubbing together, you're going to get friction. And we can see how the friction has distorted the wind direction and speed as well as it gets closer to the ground and starts rubbing against the ground. All right. Here, when you look at pressure systems, all this slide is just telling you how the winds are moving around the pressure system. As we noted before here, winds move counterclockwise around the low. If there was a high here, the winds will be moving clockwise. So I thought that was really a very good example. For all our private pilot, instrument, commercial guys, and stuff like that are in actual ground schools and ground schools, we're going to have to understand how winds are generated, like in local areas, like near the ground. So basically, what we've talked about are pressure systems and wind systems, how they act in the air. We've showed you how, when the winds come down to the surface, how the ground friction, mountains, terrain, things of that nature affect it. It's really important because as pilots we need to be aware of weather patterns and the tendencies that could be a factor during flight operations, just so we can maintain a certain level of safety. So when we have airports near, mountainous terrains and valleys and things of that nature, this is a fun place to take off. You can't just take off and fly straight out because there's a mountain waiting on you. Okay, but there's weather situations that are associated with these mountains and valleys. So the first thing we're going to talk about is a valley breeze. Let's say we had an airport, and there are situations where airports are like in a valley or on a mountain and things of that nature. So as pilots, when we get into these different areas of terrain, we need to have situational awareness. We need to understand that certain weather factors are going to happen. Certain weather factors are going to be in play. So the first thing that is required of us, we have to understand certain things like mountain and valley breezes. All right. On the left, we have a valley breeze here. Now, what's going on in the daytime when the sun comes up and starts warming stuff? All right, it starts warming the ground in this situation, and what happens? Solar radiation warms the ground warms the air. Terrestrial radiation. Now, the air on these slopes are heated. So what happens when the slopes are heated? The warm air starts to rise. Okay. And since the heated air is less dense than the air at the same altitude over the valley, what happens? We get an upslope flow. So sun comes up, warms the slopes, and then it starts rising, and then it kind of pulls this air as well. Now, typically valley breezes you can get like 15 to 20 knots. If you're at an airport that's in a valley like this, then you're probably going to get some very, very windy conditions. Now, you can put the runway here in the middle, right? So instead of taking off in that direction, you could take off towards yourself. If you're watching the screen and you had an airplane on an airfield, you could just take off towards the screen. All right. So that upslope flow is how valley breeze is basically valley breeze, and we can get 5 to 20 knots. And these speeds will hit you probably a couple 100 feet above the surface. So you have to understand, you may be landing at an airport inside this valley, and as you descend into this valley, you have to know you may get some turbulence. So it's very imperative that you get yourself in the seatbelt and shoulder harness, and make sure that your passengers have their seatbelts securely fastened. The next situation is the mountain breeze at nighttime. The higher terrain, it cools off. Okay, that ties into what we talked about in previous videos. What's going on? Diurnal variation. Okay, sun rays have been heating this stuff all day long, and nighttime comes, and now really all of this is cooling off. All right, so the cooler air, what does it do? It doesn't rise. Cooler air falls. Okay, and these speeds can reach all the way up to 25 knots. So if that airport is here in the valley and you're landing, you could have possible stronger winds as you descend into the airport in that valley. Okay. The next situation we need to be concerned with or be cognizant of is Chinook winds, or what we call katabatic winds. All right. These winds are typically stronger than the mountain breeze situation. A katabatic wind typically is any wind that is flowing down a slope. And in this situation, the mountain breeze is flowing down the slope, right? But this Chinook is not going to be a mountain breeze because, like we talked about, mountain breezes, you'll get like 25 knots tops. All right. And I need you to understand that the mountain breeze is only going to get up to about 25 knots. All right. A knot is 15% more than a mile per hour. Your car mile is a statute mile. We measure like aeronautical terms, and when we talk about speeds, we say knots. So a knot is 15% higher. 100 knots, 100 miles, 15 knots. No, I want to make sure I get this right. 100 knots is equal to 115 miles per hour, basically. So these wind speeds probably get around probably closer to 30 knots, or 30 miles per hour. Sorry. With the Chinook winds, they're greater. You still have the mountain slope situation, but the winds are much, much stronger. Basically, in this situation, we have moist air, and it's moving up slope, and it cools, gets to the top, and this is the Rocky Mountains. And then what happens is it goes down, it flows down the slope. Okay, and it's warmed, and this really the atmospheric pressure increases, and the compressed air starts to warm up. As it warms up, the molecules spread apart, and the wind's able to move a lot faster. So faster than like 30 miles per hour. So, like I said, any wind flowing down slope can be called a katabatic wind. When we use the term katabatic, we're talking about winds stronger than mountain breezes, and I think I spoke of that. Many katabatic winds occurring in local areas have been given the colorful. There's a mosquito in here. Sorry. Sorry, guys. All right. Many katabatic winds are like in different areas, and they've been given colorful names, like the Chinook winds of the Rocky Mountains. The French Alps, we have katabatic winds coming off this mountain, coming down the slope into this area. So if you live down here, it probably gets pretty windy. This is Bora Bora. This is another picture of the Rocky Mountains. Sorry about that. Okay, back to Bora Bora. Here is the Rocky Mountains, and this is the Taku Glacier in Alaska. Sometimes we may have airports that are like, you got Ocean City in New Jersey. Wow, Ocean City, New Jersey. Very, very interesting airport, and I should have just got a picture of that. But the airport is pretty much right on the shore, and during the daytime, the sea breezes hit this thing. So we have to talk about sea and land breezes. Sea breezes occur during the day, land breezes occur at night. All right. Going back to like what we talked about in our previous video, the land surface, basically when the sun rays hit it, they emit or release, they get warmer and they get hotter than the water, because there's not a lot of moisture in the land, so they kind of reflect heat a lot better. back to our beach, during the let's say around noontime, when you're walking on this beach, sand's very, very hot. Sometimes you need flip-flops even to walk on it, that the sand is so hot. So what happens here, since the land surface is warm and cool faster on the shore, usually during the day, this creates the sea breeze. Here's a sea breeze situation. Wind blows from the cooler water to warmer land. And then there's a cycle that happens. This air rises. Alright, so it's cooler air over the cool water, flows over onto the warmer land, it gets hot, rises, and then what happens is a circulation pattern where it comes back over here, the warmer air gets cooler by the ocean, gets cooled by the ocean, and then it just blows back in. Alright, and we can see our millibar system here, to just see the millibar or the atmospheric pressure levels, and as indicated, the atmospheric pressure should get stronger as we get closer to the earth. So that's our sea breeze. At night, the land cools faster than the water, so the descending air comes back in here, and then the system just reverses. So this is why at night, if you're facing the ocean, you'll feel a lot of wind blowing at your back. During the daytime, when you're on the beach, you'll feel the wind in your face if you're facing the ocean, because that is the sea breeze. At night, conversely, you're standing here, you're looking at the beach, you're facing the beach, I should say. Then the land cools faster, air comes down, and then it flows outward. Okay. So that covers this segment. Thank you guys for watching. There's more to come. Please like, subscribe, and thanks for watching.